Lesson 14, Unit 7, Laplace Transform. I'm, I'm aware that many of you haven't studied this topic, Laplace Transform. Therefore, it is going to be totally a new topic, but it's going to be very important for all of you as an engineer. And in particular, it is going to be very important for electrical engineering students because you're going to use this Laplace transform while doing practical. I think you do practicals where you need to find time period and frequency. So in those kind of practical, you might come across, equation where you need to solve using Laplace transform. Now let us look at what is Laplace transform. Now, to understand this Laplace transform, let me consider two functions. First function is fx and other function is fy. Now, what is difference between this function and this function? The difference between these two functions is in terms of variables. First function is having variable x and second function is having variable y. So there is difference in the variable of the function. Now this Laplace transform can do is using this Laplace transform we can convert the function which is having different variable to function that has got another different variable. So what is this Laplace transform is? Laplace transform is a method that will convert a function which has got one variable to function which has got the another variable. So that is a Laplace transform. It's a method that will convert the function which has got one variable to the function which has got the another variable. Now for example, if I consider, let's say you have a function, let's say you have a function fx which is let's say x plus 1, and let's say you have another function fy which is let's say it is y square minus 1. So if you look at these two functions, first one is function of x and the second one is function of y, and these two are having totally different function. So what we can do using Laplace transform is, function of variable x I can convert to function of variable y using Laplace transform formulae we can convert. So that is the purpose of Laplace transform. We can convert to a function which has got the another variable. Here when I say fx and fy, x and y could be any general variable, but here under Laplace transform we are going to convert the function which is in time domain to function which is in frequency domain. Now what will be in time domain and what will be in frequency domain? Now in time domain we will have time period. In time domain we have what? We will have in time domain we will have time period, and in frequency domain we will have frequency. So meaning we're going to convert the function which has got function of this type ft to function of fs. Now what is t? T here would mean time period, s here would mean frequency. So using Laplace transform we're going to convert function that is of time period to function that is of frequency. So basically we're going to convert from ft to function of fs. So that's what we're going to do in Laplace transform. We're going to convert function that is in time domain to function that is in frequency domain. All right, now let us go to next. Now where we use this Laplace transform. Now what is this and what is this? Now if you look at the first equation, this kind of equation is called what you call this kind of equation? This kind of equation is called ordinary differential equation. This kind of equation is called ordinary differential equation. And what kind of equation is this? This kind of equation is called algebraic equation. So we can use Laplace transform to convert ordinary differential equation into algebraic equation. Now why we need to convert ordinary differential equation into algebraic differential equation? Because it is always easier to solve the equation if it is in algebraic form. Now in ordinary differential equation, for different types of ordinary differential equation, we have got different methods of solving. But whereas we can solve this kind of algebraic equation in very simple manner. That's why we can use Laplace transform to transform or convert ordinary differential equation to algebraic equation, so that we can solve algebraic equation very easily. So we are going to use Laplace transform in converting the ordinary differential equation to algebraic. Now how we represent this Laplace transform? Let's look at how we represent this Laplace transform. Now Laplace transform we can represent like this, or we can represent like this. Laplace transform of function ft. So whatever the function that you want to convert, you have to write here. Let's say if your function is ft, if your function ft is, let's say, equal to t, so you need to write ft. Instead of ft you need to write t. If your function ft is t square minus 1, you have to write t square minus 1 here. So whatever the function that you want to find Laplace transform of, you need to write here. So Laplace transform of function ft, or we can also represent as capital F S. S means frequency. So you have option to represent Laplace transform like this or like this. Now Laplace transform formula is going to be like this. Laplace transform of function ft, or Laplace transformation of function ft being converted to s, is going to be like this. So it is running from, your integral is running from 0 to infinity, and this integration is going to be done with respect to variable t, and whatever the function that you want to convert, you need to write here. And that same function for which you are finding Laplace transform, you need to write here. If I want to find Laplace transform of function ft, you need to write here, and that and that same t you need to write here, or you need to replace this ft with this t if I want to find Laplace transform of t. And likewise, if I want to find Laplace transform of, let's say, I want to find Laplace transform of function t square minus 1. Let's say I want to find Laplace transform of function t square minus 1. So you need to write this function here, and you need to write this function here. and this s would mean frequency, this t would mean again time period. So whenever you find Laplace transform of function, this exponential function is going to appear every time. So this is just like a, this one is going to be just like a formula. So whenever you find Laplace transform, you need to use this formula. All right, now let's go to next. Now using this formula, we're going to find Laplace transform of some of the standard function. All right, Laplace transform of standard function. Find Laplace transform of the following function. Now question is, if ft is 1, if your function of t is 1, find Laplace transform of ft or find Laplace transform of 1. So basically the question is to find Laplace transform of function 1. So let us find Laplace transform of let us find Laplace transform of 1 using the previous formula. Using this formula, we are going to find Laplace transform of 1. So what you need to do is, your ft, what was your ft? Your ft is 1, right? So what you do is you replace ft with 1 in your formula. So you need to replace ft with 1 here, and you need to replace ft with 1 here, because I want to find Laplace transform of 1. So that's what I have done here. So this formula will remain same, and instead of ft, since your ft value is 1, so I have replaced ft with 1, and then I've integrated. This is definite integral, because we have a limit here. All right, so value of this one I've written here, and this one times this one, you're going to get the same value, and I've integrated this one. I hope all of you are aware or familiar with integration, since you have studied in lower class. All of you should know how to integrate. So integration of this one is going to be this. You're integrating with respect to t, right? So t is your variable. So whatever is there other than t is going to be constant, is going to be treated as constant. So when I integrate this one, this is exponential function, right? So when you integrate or differentiate exponential function, it will remain same. So integration of this one is this much, and you need to after integrating the function, you need to differentiate this one once, right? And your derivative need to be written in the denominator. So that's what I have done here. And this one is definite integral, so you'll have the limit. So one way of writing the limit is in this square box, or we can write, you can simply have one line and write like this, 0 raised to infinity as your limit. So when you evaluate, this one is going to be this one. So what I have done, what I have done here is, after integration, I need to apply the limit, right? So I need to apply the limit, meaning what your variable is t. So wherever there is t, you need to replace infinity, right? So that's what I have done. I have replaced this t with infinity, so you get this one, and you'll have the minus sign, right? So you'll have the minus sign, and then you replace this t with 0. So whatever your power is going to be here, 0. So you get this one. So e raised to 0 is 1, and what you have here is any number times infinity is going to be infinity. So s times infinity is infinity. So s times infinity is going to be minus infinity, right? So this one is e raised to minus infinity. How I have got this one is, I have taken this minus infinity to denominator. So when I take it to denominator, it's going to be positive. So that's why I have here e raised to positive infinity. Now what you should understand is any number divided by infinity is going to be 0. E raised to infinity means the number that you get from here is going to be very huge. So 1 by any very huge number is going to be 0. So that's how I have got here 1 by s. So what you need to understand is Laplace transform of 1 is going to be 1 by s. So this is Laplace transform of 1. So later on, when we deal with more complex function, this Laplace transform of 1, Laplace transform of t, all these are going to be treated as a formula. So you need to here you need to know firstly how to integrate using the Laplace transform formula, and you should remember the Laplace transform of 1 is 1 by s directly. So you have to remember the both way. You have to know how to integrate, and you have to remember the standard formula, this one as well. Now how you find Laplace transform of exponential function. This is exponential function, right? So how you find Laplace transform of exponential function? Again, you need to use this same formula. So now your ft value is what? E raised to at. So you need to replace here again. So again you need to, let me erase this one again. In that question your ft value is exponential function, so you need to replace this ft with exponential function, and again you need to replace this one with exponential function. So when you replace that one, you're going to get this one. So that function ft I have replaced with this exponential function. So I've got this one, and what you can do in next step is what you can do in next step is what I've done. I've taken out I've taken out minus common, right? Since the base is same here, what I can do is I can add these two. Since the base is same, I can write this one as like this: st plus a t. I can write like this. Now in this step what I have done is I've taken out minus from this term and minus from this term common. So when I take out minus common, I'm going to get as s minus a t. I'm going to get like this. And like previous problem, what you're going to get is, firstly you need to replace this limit to this t, then you'll have minus, you have here minus, then you need to replace this 0 with t. So any number times 0 is 0, right? So you get it is to 0. And here you're going to, in first one you have replaced this t with infinity, so you're getting minus infinity. So again it is to minus infinity means how much, what is the value? It's going to be 0. So you, whatever is left, you multiply and you're going to get this one. So your s should be always greater than a. Meaning of this one is s should be always greater than a, so that your Laplace transform is positive. Or simply you need to remember this one. If you are not able to understand this one, okay, you need to remember that Laplace transform of exponential function is going to be 1 divided by s minus a. So meaning if I want to find Laplace transform of, let's say, e raised to 3t, if I want to find Laplace transform of e raised to 3t, Laplace transform of e raised to 3t is going to be 1 divided by, you can use this formula. When you have e raised to a here, you have 1 by s minus a here, so which means I have 3 here. So Laplace transform of this one is going to be 1 by s minus 3. So this is how you find Laplace transform of exponential function. So this whole thing is going to act as a formula. So here also you need to know how to firstly integrate this one, and you need to also remember the direct result of the Laplace transform of exponential function. We have seen Laplace transform of 1 and Laplace transform of exponential function. So likewise, by using the Laplace transform formulae, we can find Laplace transform of algebraic function. Find Laplace transform of algebraic function by using that formula. So when you find, you're going to get this. So Laplace transform of algebraic function is this one, and likewise Laplace transform of t function, that is sine of at, and Laplace transform of cos of at is going to be respectively like this. So here also we need to know how to use Laplace transform formula, and after applying the formula, you should, by the integrating the function, you should know how to get this Laplace transform result by integrating. And you should also remember the direct result of Laplace transform of t function, Laplace transform of exponential function, Laplace transform of algebraic function. So you have to know both the ways. Thank you, students.